The James Webb Space Telescope has made a truly astonishing discovery. Lights that appear to radiate as though from a distant city, shimmering from a point roughly 4 light-years away. This revelation has reignited global interest in the question of whether intelligent life exists elsewhere in the universe. The telescope turned its powerful lens toward Proxima Centauri b, the nearest known exoplanet to our solar system, where it detected curious and unexplained bursts of illumination. Could these be indicators of an alien civilization? The world waits eagerly for further insights. For years, both scientists and laypeople have been captivated by the possibility of life beyond Earth. Any scientific hint pointing toward extraterrestrial existence is often met with widespread excitement and speculation. A major turning point came when the James Webb Space Telescope presented compelling evidence that suggests life might indeed exist somewhere in the cosmos. While surveying the vast reaches of space, this advanced instrument picked up signals on Proxima Centauri b, flashes of light resembling those from cities, possibly artificial in nature. The notion that such a civilization could exist has fueled immense curiosity among researchers, who recognize that this could be the breakthrough they've long hoped for. The implications suggest intelligent beings may be structuring their societies in ways still unfathomable to us. These city-like lights, visible from a staggering distance of 4 light-years, have left NASA engineers in awe. It raises a question. How long have these signals lingered in space, awaiting the evolution of human technology to detect them? David Kipping, an astronomer at Columbia University, described Proxima Centauri b as an unusually complex planet. Unlike most rocky planets that absorb sunlight and release energy as infrared radiation, Proxima b behaves differently due to its peculiar interaction with its parent star, Proxima Centauri. This distinction underscores the importance of the James Webb Space Telescope, whose capability to detect infrared wavelengths was vital in identifying the planet's strange radiative patterns. Scientists aim to continue observing Proxima b to better understand its atmospheric conditions and assess whether it could support life. The telescope's heightened sensitivity to infrared light enables it to monitor activities on Proxima b's night side, something few other telescopes can achieve. In the vast expanse of space, detecting such faint glimmers is extremely challenging, but the James Webb Telescope is capable of picking up even the most subtle light signatures. This precision makes it an indispensable tool in verifying whether the observed lights on the planet's dark side are, in fact, artificial. If the light falls within a narrow frequency band distinct from natural stellar emissions, it would strongly suggest an artificial origin. Proxima Centauri b's relationship with its host star is highly dynamic. As the planet rotates, it experiences a day-night cycle similar to Earth's, with intense heat during the daytime and significant cooling at night. These temperature variations are largely influenced by the planet's composition. If Proxima b lacks an atmosphere, the differences between daytime and nighttime temperatures would be extreme, resulting in a sun-facing side that becomes scorching, while the night side freezes to sub-zero levels. This stark thermal contrast intrigues astronomers, as it provides essential clues about the presence and makeup of an atmosphere. Thanks to its proficiency in capturing infrared imagery, the James Webb Telescope can analyze thermal emissions from the planet, offering valuable insights into its atmospheric profile. Another fascinating aspect is the telescope's orbital timing. It matches Proxima b's 11.2-day cycle around its star, enabling consistent, detailed observations of the planet's light and temperature patterns. If an atmosphere is indeed present, the next step for scientists is to investigate its chemical makeup to assess habitability. The presence of molecules like oxygen, methane, and water vapor would signal that the planet might support life. This process involves studying the starlight that passes through the planet's atmosphere, a complex but critical undertaking. Although the James Webb Telescope is optimized for detecting elements such as carbon dioxide, methane, and water vapor, It has limitations in identifying free oxygen, a key biosignature. However, it can search for other important indicators like ozone, which also suggests a viable and potentially life-sustaining atmosphere. As astronomers continue analyzing the telescope's data, the pursuit of distant worlds persists, bringing us ever closer to answering one of humanity's most profound questions. Are we alone in the universe? It is essential to note that the James Webb Telescope can only observe a limited number of exoplanets near Earth. For more comprehensive atmospheric studies, researchers are preparing to rely on next-generation ground-based instruments, such as the Extremely Large Telescope, ELT, which is expected to become operational by 2028. The ELT is poised to provide in-depth views into the atmospheric structures of far-off exoplanets, generating clearer and more detailed data regarding their potential to support life. While future space observatories are under development, the James Webb Telescope remains a cornerstone of exoplanetary exploration. Despite certain limitations, it continues to deliver groundbreaking insights that may ultimately reshape our understanding of what lies beyond our solar neighborhood. Scientists are now focused on building advanced space telescopes capable of reducing starlight, thereby enhancing our ability to observe the faint glow of planets orbiting those stars. This process is similar to using your hand to shield your eyes from the sun to see an object more clearly. By dimming the overpowering starlight, these instruments can better examine exoplanetary atmospheres and determine whether they host life. Yet, this goal presents a significant technological hurdle. Stars are incredibly luminous, outshining their planets by vast magnitudes, which makes detecting faint planetary light extraordinarily difficult. To address this challenge, scientists are developing groundbreaking technologies. One such innovation is the coronagraph, a device integrated into telescopes that blocks out direct starlight while allowing light from orbiting planets to pass through. By manipulating light waves with extreme precision, coronagraphs dramatically reduce stellar glare and make the faint glow from exoplanets more visible. Another exciting development is the Starshade, a massive, flower-shaped spacecraft that travels in coordination with a space telescope. Positioned tens of thousands of kilometers ahead, it blocks starlight before it even enters the telescope's field of view, allowing only planetary light to reach the sensors. This technique holds great promise for observing planets within their stars' habitable zones, where liquid water, and potentially life, might exist. These technological advances demand extraordinary accuracy. For instance, aligning a star shade requires precision to within fractions of a millimeter over immense distances. Additionally, these instruments must be engineered for the harsh realities of space travel, including being lightweight, energy efficient, and highly durable. Nonetheless, the potential rewards are monumental. Successfully observing and analyzing an exoplanet's atmosphere could lead to the discovery of biosignatures, chemical traces that point to life. Gases like oxygen, methane, and water vapor in particular ratios could hint at biological activity, offering compelling evidence of extraterrestrial life. Researchers are also working on ways to obtain sharper, direct images of distant worlds. Future telescopes may include advanced adaptive optic systems that correct for distortion caused by Earth's atmosphere or instrument movement, resulting in clearer visuals. When combined with starlight blocking technologies, these enhancements could enable scientists to not only detect exoplanets, but also create maps of their surfaces and study their climate systems. The progress in space telescope technology represents a monumental leap in our ongoing mission to determine whether life exists beyond Earth. By advancing our ability to study distant planets, we inch closer to answering the timeless question of whether we are alone in the cosmos, potentially revolutionizing humanity's understanding of our place in the universe. What are your thoughts on the possibility of intelligent life beyond Earth?